So yeah, I'm Michael Feldman, Intersect360 Research. I just introduced myself a few minutes ago, it seems like. So we're a market research firm in Silicon Valley. Actually, we're all around Silicon Valley. There's the four of us, Addison Snell, who usually does these things. He heads the company, and we have Chris Willard and Laura Segerval, who also is with us. Let me just move on. Am I doing that right? There we go. It's a little characterization of what we do. This isn't actually brand new. We have this organization called HPC 500. It's an end user group we've assembled to collect data from users, obviously, and we trade that basically for free access to our research. And we do calls on a pretty regular basis on topics of interest that end users are interested in. Those are actually very interesting calls. I've been in on a couple. I think one of them we discussed processor technology and what the users, or what some of these users are thinking is on the horizon, and it's a lot of insight into that. And we ask those users to fill out a survey like once every 6 months or so. Some of these are fairly long surveys. They take about an hour to do. But the value of the organization is good enough that they're willing to do that. We have basically two types of surveys we do. Something called a site census survey. Basically, we say, what's at your site? How many computers do you have? What do your computers look like? How many nodes? What are the processors? How much memory? That's why it takes so long to put together. And then we do a budget map survey, and we say, how much money are you spending on each component of your infrastructure and your software and services? And we go through, again, servers, storage, software, power, cooling, that sort of thing. We break it down into categories. So those are our basic two foundational surveys we do. Just moving on, we do a podcast every week. Actually, I do a podcast with Addison Snell, and we distribute that with help of insideHPC, but it's also on our website, and there's our Twitter account. What is new, we're in the midst of an impact survey on the exascale for industry, seeing the demand by industry for that technology, and so we're doing that work right now, and I can't remember when the final report is due, but it's a long-term survey and report. We also have newsletters announcing our research, articles, and the podcast I just mentioned. If you want any of those things, go to our website, sign up at intersect360.com. What did I do? That's not good. Here we go. So this is sort of a snapshot of the past year. We don't have the 2013 figures in for revenue yet. We're just getting those assembled. We should actually have that within the next, I would say, 2 or 3 months. So the latest full year figures we have are 2012. This just shows sort of the change from the previous year. In general, the growth over the next several years is around 6 or 7%, but obviously within the different categories, the revenue is a little more choppy. 2012 was a weird year, especially for storage, because of the flooding in Southeast Asia in 2011 kind of ruined a lot of the disk capacity that was going on in mainly Thailand there, and everything got backlogged. And then in 2012, when the disk storage manufacturing came back up to speed, it just flooded it again. So a lot of the revenue got deferred into 2012. Usually the growth is better on storage than some of these other sectors, but not 26% a year, so that's not going to happen again. Whoops, wrong way. This is a breakdown of how we sort of cut up the markets. We basically segmented into two general markets, something called high-performance technical computing and high-performance business computing. The technical side is the ones probably the majority of people in this room are interested or familiar with. It's science and engineering, all the applications that have to do with that. Whether it's energy or bioscience or physics research, whatever. There is some commercial in there, though business is not just commercial, there's commercial on this side. You can see in this corner, 41% of science and engineering is commercial still. The other segment, the other big super segment is business computing. That's financial services, online games. We include media and entertainment, and even ultra-scale internet, which we think has enough characteristics of high-performance computing to include that, and also retail and transportation. The thing you don't see from this this chart is the technical computing super segment is actually twice as big as the business computing segment. So just imagine that pie there is twice the size of that one. You'll get a feel for it. And even though that's the case here, financial services, which is on the business side, is now the largest segment in HPC from our surveys. It's actually just a little bit bigger than manufacturing now, which includes all the little manufacturing sub-segments, product manufacturing, or large products including, and then consumer products, and it includes aero and auto as well. So financial services is just a little bit bigger now, and it's probably going to continue that way. Can't remember if I was going to say anything else. The private sector in general is growing faster than the public sector. We see that going on for the foreseeable future simply because a lot of governments, US, Europe, Asia, are sort of scaling back in general, and commercial applications, commercial companies are catching on to HPC more and more. So whereas before the public sector sort of drove the industry, we're seeing now that's sort of turning around. It could turn around again, but for the future, we're looking at the private sector is going to grow a little bit faster. And this is just from Chris Willard, my colleague. He says when you create a forecast, it has to be bound by what is realistic, whereas reality itself has no such limitations. Basically, I think that's a polite way of saying shit happens. We don't foresee things like recessions, depressions, government sequesters, flooding in Thailand, things like that. But they do happen. And in fact, whoops, wrong way again. Here's our general forecast, but now we're even seeing, in the US, of course, there was a government sequester, so from 2012 to 2013, I think we're looking at like 6% growth there from those years across the whole, all of HPC revenue, but that's probably because of the government cutback is going to come in a little bit low this year, or I should say from last year. We're probably not going to see quite a 6% growth there. The government sequester has been ameliorated slightly, but not enough, and we couldn't really forecast that. But in general, what you see is a 6 or 7% CAGR there over the next 4 or 5 years, and then the total sum is going to be $35 billion, somewhere around 2017. The other thing you might notice from that chart is servers, or hardware in general, is about half of it, and you have software services, is the other half. Servers itself is about 1/3 of the market, but it's not growing quite as fast as some of these others. Storage, like we just talked about, is growing a little bit faster. Networks is doing a little bit faster as well, and you can see software seems to be growing at a little bit faster clip than the industry in general in total revenue. So from our user site census survey and report, the primary challenges users are sort of indicating there is how they sort of want to balance the processors per node, the cores per processor, memory, I/O. There's all these configurations out there, but some parts are very expensive. There's memory limitations on capacity. That's becoming very expensive. There's a big choice of core count now in the processors. It used to be you did either 2 or 4 cores. Now you have a whole range, anything from quad cores, 8 cores is sort of the sweet spot now, up to 16. So balancing all those things is a little bit of a dance right now, and depending upon your application, you want to put different things together. So people are trying to figure out what the balance is for their application set, and that can be difficult because if you're running 100 different applications, you have to sort of make some compromises there. The other big challenge is how to adapt the applications to the parallelism that's occurring as you expand cores, and in some cases even expand sockets on the node. How are you going to do that? Obviously, we're still seeing MPI out there, but people are looking now, of course, with accelerators. They're looking at CUDA. They're looking at OpenACC as a model for accelerators, even OpenCL, and some of these others. There's OpenMP now has the accelerator annexed to it as well. None of these things are quite compatible with each other. Or I shouldn't say that. OpenACC and CUDA are, but the others aren't quite there. I think at some point, some of these may integrate into each other. We'll have a more regular programming model that's applicable across multiple architectures now. Some of the other issues, how to organize the job mix, whether you go to smaller nodes or larger nodes, that sort of thing. That's sort of another pain point there. The memory configuration is very interesting. That's sort of a subset of what I was talking about. We're seeing memory in general grow per node quite a bit. That's mainly a function of there's more cores per node, and you want to keep basically your memory per core at least at what it was in previous generations. So as cores grow, you see memory grow per node, and that's growing faster. But even memory per processor is growing at a pretty good clip, again, because of the core count. The most interesting thing, even though that looks like a flat line there, memory per core, actually that's growing too. And I noticed some people here, and even you hear generally out there in the community that memory per core is flat or even declining. We're not seeing that. We're seeing that grow too. And it was flat for a while, and then past 2 years, it's grown as well. It's now at like on our survey, it's like 4 gigabytes per core. I think when we started out, it was at like 1.7 or 1.8. That's sort of important to me because that means as you build these systems, that's becoming a bigger and bigger slice of your system cost. And if you're doing that, that means you have to cut back somewhere else, either in storage or processors or total size of system. So it seems like users are favoring memory now over some of these other components because the memory is usually a limiting cost factor on systems. So that's something we're going to continue to track and see if that flattens out again or even reverses. But people right now seem to be kind of memory happy, at least the users we're surveying. Accelerators, we've been tracking this for a while, very interesting trend. It's a little jumpy. As you can see, we started doing the survey in pre-2008. I think the first accelerators came out a couple years before that. 2009 looked like a bit of an anomaly, but you can see the general trend is up. Now we're at like the latest year we track this, the new systems that came out in 2012 or after, about 44% of all new systems now have accelerators. And of the ones in the field that have accumulated there, not just last year, about a quarter of systems out there now have accelerators. And we're thinking, we haven't got the figures in for this year, 2013, obviously not 2014, but I have a feeling this year, when we look at the surveys, there's probably half the systems that are deployed this year will come with accelerators. It seems to be on that path, especially with the introduction of Xeon Phi, which is, I think, maybe even helping NVIDIA to a certain extent, but also is creating sort of a different opportunity for customers who, for whatever reason, didn't want to accelerate with graphics technology. They wanted to stick with x86. So when I say we'll see half of the systems deployed maybe this year with accelerators, that might even be conservative. We might see a bigger jump just because of the Xeon Phi introduction. Challenges. So some of these things have already been talked about today, obviously. Power consumption and the cost of memory, which I just talked about. there's new models of parallelization. Again, we're getting MPI plus something on the node for on-chip or on-node parallelism. And the languages and programming models, the ones I just talked about, OpenACC, OpenCL, AMD has its own, well, it's sort of committed to OpenCL and another, the HSA programming model for them. System efficiency is another challenge, just the balance of compute versus data movement, basically. And then personnel for administration optimization. So just keeping people trained and looking down the road, having new people come on board that have expertise in HPC obviously has always been a challenge, and now we're looking down the road where older people are always retiring, and now where's the new blood coming from? It's still sort of a niche market, and it's always difficult to get people to move into this market, but certainly the community is always concerned about this and always is looking for new talent there. This is a real challenge as people try and enter into HPC. The entry level is one of the barriers that people don't have the expertise to run or maintain or buy or procure HPC systems, so sort of that intelligence part of it has always been sort of a barrier there. Again, this is notes from the last supercomputing show, which is actually several months old now, but just thought some of the things we've already mentioned, Pizdant. There weren't that many big system announcements at SC. The only one I could think of that we noted was RSC Group, the Russian company there that was talking about their petaflop and a rack system. It was sort of a slow year for new systems at SC this year. The processing was bigger news. NVIDIA announced the Kepler K40 with some new features. And we noted that the Kepler itself, not the K40, but the K20 dominated the Green 500. I think they had the top 10 systems on the Green 500 this year came from K20 accelerated systems. And then on the other side of it, Intel talked a little bit about the Knights Landing Xeon Phi at SC. They didn't reveal a whole lot, except it's going to be, sort of a standalone socket capable system with some interesting memory configuration as well. So it looks like they're moving Xeon Phi into more of a processor than just a coprocessor architecture, although for the time being, Knights Landing will also be available as a coprocessor. So that's something to watch, definitely. I think we'll find out more about Knights Landing coming maybe at ISC in a few months, and certainly by the time SC 14 rolls around this November, they'll probably release some more details. It's not going to come into production until they get the 14 nanometer technology rolled up, and they didn't talk about exactly when that would be for Knights Landing, but we're probably looking towards either late this year or 2015. Then the other thing that was talked about at SC was the Micron Automata chip, which is just something surprisingly that Micron, which is a memory company, basically came up with, and I think it's basically an experimental thing, but sort of new technology that they're looking at that might catch on. Micron seems to be more and more interested in HPC these days for whatever reason. Of course, they're driving the Hybrid Memory Cube consortium, and they're going to release. It looks like they're going to release their Hybrid Memory Cube technology into the field sometime later this year, maybe in a smaller system that is TBD. There was also talk about liquid cooling, which includes now warm water cooling, which is the big thing in HPC now. There's no more, people don't want to do cooling systems anymore. They just want to do warm water, and you just cool it with ambient air temperature, which is much cheaper. And now the componentry in HPC can run with warm water cooling. Also, there's under that topic of liquid cooling, there's also now these oil-cooled racks that you might or might not have seen. The Green Revolution computing, or Green Revolution cooling, I should say, has been out for a while, and I think one of the smaller systems in Japan is using that, and they got to the top of the Green 500 list. It was the Tsubame KFC system, and they blew away the competition on the Green 500 just with oil-cooled racks. Some other notes from SC. There was some new announcements in storage, which we've been talking about a lot today. There was the NetApp, some NetApp announcements of their E2700 and their E5400. Xyratex, which we've heard a lot about, the Cluster Store 9000 they announced, and including the grid-raged parity decluster technology in the gateway. DDN announced the infinite memory engine with the burst buffer using non-volatile RAM at that conference as well. Big data was a big theme at SC13. Every time you turned around, there was some big data session or opportunity or booth that had to do with it. There was actually less traditional supercomputing themes this year than big data, but it was interesting to see, and certainly if you're in this community at all, you realize that the overlap between big data and sort of the integration with HPC is quite remarkable, and I think this will continue for a while. And there was also some companies talking about object storage. We just heard Torben talking about it quite a bit, and it's not a technology that's being adopted by the user community right now to any great extent, but it's something the vendors are definitely talking about for obvious reasons, and I think this is going to be a technology to watch for sure. So, looking ahead now, let's start with the cloud. In general, our view of the cloud is it's sort of a low volume market in the HPC space. I mean, the cloud, people talk about the cloud in a lot of different ways. Here, we're talking about like public cloud. So the private cloud is a little bit different. Here we're talking about something that you can buy utility that's external to your site. And in that sense, it's not like it's not common in HPC, in the HPC user community. I think about 25% of HPC users say they use the cloud to some extent, but only for about 5% of their workloads. So that doesn't work out to too much. It was $600 million spent in 2012. About half of that was just for raw cycles. And it's growing at about the same rate as the HPC market, which is, like I said, 6 or 7%, but it's only about 3% of the budget for all of HPC. So it's not a big chunk. And we don't really see an inflection point for that either. There's nothing that's occurring that would show that all of a sudden people are going to start using like tons of cloud and ditch their on-premise clusters. Now, private clouds are a little different. I mean, private clouds, it's basically your on-premise cluster, maybe a very well-managed on-premise cluster that you can farm out and run a lot of diverse workloads on, or maybe an aggregation of clusters. That's not what we're talking about here. Certainly, I should move ahead. That's an opportunity, certainly for vendors that we're talking to. Private clouds are well adopted in this community, coming out of when it used to be called grid. So it's just evolved into these private cloud things. But we're telling vendors in this field, if you're going to sort of attack the cloud market in HPC, think more about hybrid systems where you can do bursting to the cloud. I mean, right now it's sort of overcompeted for the size of the market, the HPC market, and since we're not showing great growth, there's no reason to make this big push at this point. It's not as big a market as many vendors think. How many people here, how many users use cloud computing at all? I was just wondering. Just raise your hand. One? How many people are users here? Just raise your hand if you're a user. Yeah. I mean, if Yeah, applications, okay. Now that sounds about right. Okay, so about a quarter. So it's something we're keeping an eye on. We did notice a slight uptick from the last time we took the survey. It was like a 2.8%, now it's 3.4%, but again, we don't see it getting that much bigger very fast. HPC and big data, that's another story. Big data is definitely a much more interesting market here. The problem with forecasting big data, we can't even size the market. I mean, we can't do it like we do HPC. We can't say this is a big data cluster, because usually these clusters are used, usually the platform for big data is used for multiple purposes. So you can't go out and buy a big data server so much anymore. You can't do it at all, because usually it's working as part of your enterprise or part of your scientific cluster. So that part of the market is not really, from a revenue standpoint, isn't forecastable. I know there's some analysts that do forecast size for big data, but I'm not sure what they're counting, because on the hardware platforms, it's, like I said, it's very nebulous. There's very little information out there that says this hardware platform or this set of infrastructure is only for big data. If you were thinking just about applications, I could certainly see that. You could buy analytics applications or other pieces of software that are definitely big data oriented, but for the whole piece of infrastructure, that's hard to do. So we don't really forecast revenue size there. We did conduct a very thorough survey in 2011, and we just updated that for 2013. Not just technical users, also business users for big data. So the insights from that was big data is certainly a big opportunity. It's 20 people that wanted to use that sort of technology. About 25% of their budget was going to go towards big data infrastructure of some kind, and I think a lot of that was going to be software. The second big insight was it's not just Hadoop. In fact, it's really very little Hadoop. About less than 20% of all sort of the application frameworks that people were using was Hadoop. Most people were using their own frameworks of one sort or another. It was a large list. I mean, Hadoop was there, and it was probably the biggest slice of the pie of all of them, but it was less than 20%. So if you've got if you're a vendor and you offer Hadoop as a solution, you're missing 80+% of the market, because most people are doing custom work right now. And in fact, in the latest survey, the slice actually went down. There's less people using Hadoop as a percentage. Probably not less people using Hadoop, but as a proportion. The number 3 insight was, maybe not for this crowd, but performance matters. But that was also for the enterprise customers on this side. For big data, unlike some of their other application sets, performance does matter. Usually, if you're on the enterprise side, it's reliability, it's RAS. But this particular application category, it has more of the characteristics of HPC. Performance is king, reliability is secondary. Actually, Addison Snell had a full presentation on big data. This is from the Software Developer Conference he did several months ago. If you follow that link, you can see the full presentation on big data. It was quite an interesting survey, and it was sort of an eye-opener for a lot of the trends we've been looking at for that super segment. So the other thing we're looking at now is the Lenovo deal that we've been talking about. In our survey, IBM was in the number 1 revenue position for servers. I know sort of people think they're sort of equal with HP, but IBM was on top. That obviously included their x86 server system. So with the sale, we're not sure who's going to be in the number 1 position in 2015. Presumably that'll go through, the sale will happen, and then 2013, you've got IBM, they've retained their supercomputer business, their Blue Gene or the follow-on to that, as well as their power systems, but that wasn't the largest part of their revenue for HPC servers. HP, I think, was number 2, and then Dell was in there. So right now it's going to be up for grabs. Lenovo will probably capture a lot of the market, but they're not necessarily going to be number 1 either. I think it could be anybody. IBM itself is going to continue to compete in HPC, but with a very application-centric point of view. Basically, this is a move which has gone on for a long time for IBM. They're basically getting out of the volume hardware business, certainly, and they're just moving towards a more application-centric view of everything. I mean, you think of what they're doing with the Watson technology. They don't sell that as a power system, really. I mean, they've hosted it on power, but they'll host it on anything they have. They're looking at these technologies from an application point of view, and I think that's how they're going to start to sell HPC as well. The Lenovo sale also, I think, points to a more competitive picture with IBM and Intel. Intel basically has jettisoned sort of the last link it had with Intel, which I don't think it was in love with anyway. So now it can focus on its own hardware platform, which is Power, which they've now opened up to be the Open Power model, and their collaboration with NVIDIA, and a few other things. Now it seems like there's like an IBM axis and an Intel axis, so that's lining up to be sort of an interesting competition that I think is going to play out over the next few years. The deal also gives some opportunities to everybody else who might be trying to pick up some of the IBM business if people aren't comfortable with Lenovo, HP and Dell, Cray, SGI, Bull. They might think there's an opportunity here now that Lenovo is now a foreign-based company, at least, and there might be some, and it's not IBM anymore, so there might be some customers who will now start to look at other vendors, especially in HPC, where there's not a whole lot of brand loyalty. I mean, if you could talk about brand loyalty with anybody, it might be IBM, it might be Cray to a certain extent, but even there, with generic x86 clusters, there's not a whole lot of loyalty. Also, there's secondary opportunities for AMD and NVIDIA now. Let me just move on. So other stuff. So our opinion, I don't know if it's our opinion, we've got four analysts. I think we have all somewhat different slants on this, but I think with the latest announcement by Japan and Riken, they look like they put a stake in the ground to get their first system up and running in 2019, and to go into production in 2020. But I think they could get, if they're going to have it installed in 2019, they'll certainly get a LINPACK run there. I sort of trust they're going to do that. Remember, Japan was the country that put together the K supercomputer, which was part of a program where two of the three main contractors dropped out. It was Hitachi and NEC, and they still hit the deadline, which in that case for the K supercomputer, I think it was 2012, and they stood up a 10 petaflop supercomputer on the date they said, basically on the date they said they would. I don't think they'll miss it this time either. It looks like they know what they're doing. The contractors are the same, though. It's Fujitsu, NEC, and Hitachi again. Presumably they'll all stick it out this time. They haven't said much about the architecture or what they're going to do, but it looks like it'll be some evolution of the K supercomputer of some sense, although I think there's 2 or 3 sort of straw man proposals out there on what it's going to be. But they're basically the only country that's put their stake in the ground. China could definitely come up with something in the interim, but they haven't said anything public. And the US, I think, has basically given up on getting something out before 2020. The latest thing coming out of the DOE is they're looking at the early 2020s. So unless something changes in the next 6 or 7 years, and certainly that could, it's going to be either Japan most likely and possibly China. Even somebody in Europe might beat the US at this point. There's just not the, doesn't look like there's the will politically to put out money right now. Again, that could change, but right now I think they're going to be a little late. Not that any of this matters. I mean, we make a big deal out of the first exascale system, which is, right now is defined as an exaflop LINPACK. But, remember the first petaflop system was Roadrunner, and that architecture no longer exists, and most of the applications are now running on very different types of systems. So first system is sort of nice for prestige, but it's liable to be, if not a one-off system, then a very specialized systems. The ones that come after that will certainly get as much attention and certainly as many applications drawn to them. So I don't want to make a too big deal about that, other than, I think basically exascale will arrive sort of in that timeline that we originally thought, or shortly thereafter. Accelerated architectures, we think, is going to be the future for the volume HPC. Even though we said most use cases haven't been proven out yet, and since we're still, even though there's a lot of them out there, there's not a lot of production work going on, even though they're definitely penetrating the market very quickly right now. With Xeon Phi, like I said, it's become, it's getting a lot of attention now. They're going to get a lot of trial systems. In fact, they're getting as many trial systems as the GPUs are now. ARM obviously still a 32-bit, but once we see those come with the 64-bit implementation, there's going to be a lot of trial. We've seen interest in the users we've talked to about 64-bit ARM. People are looking for an alternative to Intel and maybe a more friendly power envelope than maybe x86 has offered as well. The other interesting thing about ARM is that it has a different business model. I mean, I think the energy efficiency argument, why it might be valuable, is one thing, but Intel itself is working on very energy efficient systems with low power Xeons and their Atom portfolio. I think the more interesting thing about ARM is its licensable technology, whereas Intel and AMD are the only two companies making x86. ARM is licensed to dozens of companies and could be licensed to dozens of more companies. We're seeing about half a dozen vendors that are talking about ARM64 right now. Not all of them are aiming at HPC, but that could change. And even Samsung is looking maybe to put a 64-bit server chip together with ARM64. And just to keep that in context, Samsung is a bigger company than Intel. So there is room in a market for new architectures to do other stuff. I mean, there's FPGAs, there's DSPs, I mean, TI has put together different things. There's all sorts of interesting things coming out there. I didn't talk about it here, but Torben talked about the memory cube to an extent. And I think just from the latest stuff I've seen about people talking about exascale, it looks like people are looking at 3D memory as a way to help solve the memory capacity and bandwidth problems in the extreme scale systems, which will filter down to just everyday systems. The recent announcement at the GPU Technology Conference last week, really, 1 minute, they talked about their 3D memory technology going into the follow-on to the Maxwell GPU. So I think everybody's starting to think very seriously about 3D memory, and I think we're going to see that in the second half of the decade. And then watch for shifting OEM alliances as some of these sales of companies and integration of other companies play out, especially with Lenovo. So we've talked about that.